So, welcome to the first, officially first video regarding the preparation of this ISTQB test. So, as I told you that we will go through the content and we'll see in detail uh, by reading all the important stuff which actually is like important as far as test is concerned. So first of all, in the start of every chapter you have some keywords which are mentioned actually, and you have to, like, it is a kind of summary which you through which you will come to know that which topics you are gonna cover during each chapter. So for example, in the first chapter we have some kind of coverage, debugging, defect, error, failure, quality assurance. Some keywords are there. So by the end of this chapter, you should be able to answer or to tell like what exactly these terms are. And so in the first chapter, if you see, we have in total. I will shortly go to the course content actually, so that over there we can see how many topics actually we have in chapter number 1 itself. So in chapter number 1 we have 1.1, like what is testing, then why testing is necessary. 1.2, 1.3 is about 7 testing principles, 1.4 is about test process, and 1.5 is about psychology of testing. So we will try to cover all of these topics, 5 topics, so 5 videos from chapter number 1. So currently we are on the first video, and here we will start what is testing actually, and what are the objective of testing. So software systems are an integral part of life, from business application, e.g. banking, to the consumer product, e.g. cars. Like, software are everywhere. If you are in the world, you have a mobile phone with you, you have a laptop with you, so everywhere there's a software. Most people have an experience with a software that did not work as expected. Sometime we have a software which is not working as we are expecting. So what is the problem actually? That means that this software is of poor quality, it is not fulfilling the requirements of the customer, and maybe it is not tested properly. So software that does not work correctly can lead to many problems, including loss of money, time, or business reputation, and even injury or death. So if your software is not working properly, then sometime it costs you money, sometime it costs you your reputation as well, and even sometime injury or death. In aeroplanes, in cars, everywhere, in electronic items, we have the software installed. Even if I will take an example of automotive domain. If your uh, braking system, the software braking system, is not working properly as it is expected, then you will have some real problems. So that's why software testing is a way to assess the quality of the software and to reduce the risk of software failure in operation. So during operation, maybe there are some failure of the software. So you have to test. As the software is completed, you have to test it first, and then only you can take it to the production. So testing is very important as far as your public reputation is concerned, or your safety, or your life is concerned. A common misinterception of testing is that it only consists of running test. We have I executing the software and checking the results. We have a very common misconception that what does exactly testing mean. That means that we are running some test cases. We have the code, and we have drive some test cases, and we are running the test cases to see if the software is working or not. But actually, the software testing is a process. It's not only about running the test cases. We will see more details in upcoming chapters, that it's a kind of steps. Software testing has some steps, and if you say execution of your test cases, actually it's one of the steps of your software testing. Software testing is a huge domain. Like, even you can go for we will see what is static testing, and running the test cases is dynamic testing. So we will see in detail about all of this in upcoming chapters. In section 1.4 they will tell that software testing is a process which include many different activities. So test execution like checking of result is only one of these activities. For example, you have requirements ready, then you can review it, you can read that if the requirements are fulfilling the customer requirements as well, or you see the requirements written document, it could be a Word document, it could be a PDF document, or whatever tool you are using. You see the requirements and you say that it's not logically or practically possible to implement this requirement, so it's a kind of static testing. So testing is a huge contains a huge definition or huge topics in it, inside it. So executing the software is one of them. The test process also include activities such as test planning, analyzing, designing, implementing test, reporting these test progress and result, and evaluating the quality of test object. The whole software testing actually is a combination. We will see the test process in detail in this chapter. It starts from planning and implementing test, or executing test is only a part of these steps. So if you come across the word software testing, then that's a huge definition. It contains the planning as well, test execution and everything. So like, this is a kind of a bit tricky word, but you should be familiar with that. Some testing does involve the execution of component or system being tested. Such testing is called dynamic testing. Yeah, in that part of testing where we are running our test cases, actually you can say it's a dynamic testing. You have the code, you have written down some test cases, and you are executing them either using some manual testing or using some automatic testing or using some tool. You are executing those test cases and getting the result. So it's a dynamic testing. But there is also static testing. Other testing does not involve the execution of the component or system being tested. Such testing is called static testing. Static testing means you are not actually running your test cases, but you are looking. For example, when the code is ready, before running the code, we can have a review. Like normally our teachers, when we were studying at university, and even in our company where we are working, some of our colleagues can review our code, that you have written down the comments properly, you have declared the variable which have meaningful names. So it's a kind of static testing. Even you got requirement from customer, and then you review it if the customer's requirement is really practically possible or logical. So it's also kind of testing, which is a static testing. So testing includes reviewing work product, any kind of work product. Work product can be, we can write it short as WP. Work product can be your documents, your software requirement specifications, SRS, or whatever is it. It can be a work product such as requirement, user stories, source code, anything. And if you are not running it, you are only reviewing it, you are only looking into it and finding some discrepancies and some issues, it's a static testing. But when you have the code and you are running your test cases on it, then it's a dynamic testing. Another common misinterception of testing is that it focuses entirely on verification of requirements, user stories, or other specifications. Like they are saying here, like there is another misperception about the testing, that it only focus on the verification of the requirement, user stories, or other specification. That like, if we are only verifying user has given this requirement, our code is fulfilling those requirement or not. But while testing does involve checking whether the system meets specified requirements, it also involves validation, which is checking whether the system will meet user and other stakeholder needs in the operational environment. So there are actually two different terms. One is verification, in which actually you see that the software you have developed is working properly, it is getting the exact values from the database, or my test environment is working as expected, and you are looking into everything. But when it comes to the validation means that either my if still my software is working perfectly, there is no bug in the code, but still is it fulfilling the requirement of the customer, will my customer be satisfied with that? So then this term, to fulfill the customer requirement, it's called validation, which is checking whether a system will meet user and other stakeholder needs. It's quite possible that your software is bug free, typically, like you say, it's working properly, but maybe your customer is not satisfied with the product. So you have to keep two things in mind. One is verification, in which you verify your software is working properly, it is interfacing with other modules properly. That is your internal checking. And then, as per the need of customer, you have to validate it, and it is called validation, which we have seen here, the term. So now we will come to the typical objectives of testing. Actually, what are the objectives of testing? What exactly, when we are planning for a testing, then uh, what should be our objectives? So objectives could be to prevent defects by evaluating work products such as requirement, user stories, design, and code. Actually, testing, as I told you, testing can be static, in which you will review your work product, you will review your requirement, your code, your user stories, your epics. We will see all of these terms in detail in future. And then there is a dynamic testing, actually, in which we will run our code. So if the objective of testing actually is that you have to prevent defects, by evaluating your work products, you see your work products, which could be requirement, user stories, your design, high level design, low level design. We will see everything in detail in chapter number 2 as well, and code. So actually, a typical objective of testing, the main objective is to find the defects, and like this is the responsibility of testing team to prove that faults will cause some failures, to find the defects either in the work products, in the code, or even in the requirement, or anywhere, using techniques of static testing or dynamic testing. Then, to verify whether all specified requirements have been fulfilled, this is also a kind of requirement. You got requirement from customer, and then you modified it for the high level design. And so you should know the fact that either your all of the requirements are fulfilling the customer needs. This you can also do when your requirements are ready. Then the other objective is to check whether the test object is complete. You also need to check that your test object, actually the thing which you are testing, is complete. Test object is a basic term. Anything which you are going to test, normally it is known as test object. So we have to see that our test object which we are testing is complete, and validate if it works as the user and other stakeholder expect. To build confidence in the level of quality of the test object, even by doing this testing, actually you are sure that your quality of your test object, either it can be your requirements, or you can say your code, it it has no bugs in it, no ambiguity in it. So then you will have confidence that now you can go ahead, actually, with your test object. To find defects and the failures, thus reduce the level of risk of inadequate software quality. Actually, there is a concept of early testing. You want to find the defects and failure as soon as possible. Either it is in the requirement. If you find that defect or bug or in the missing requirement in the early phase, then it will not replicate to the code. Your code will be developed, like if the requirement is not good, the code which is developed is also not good, because the code is developed on the base of requirement. So that could be a risk. So that's why, thorough testing, you can find defects and failures, and risk of inadequate software quality will be reduced. Even you can provide sufficient information to stakeholders to allow them to make informed decisions. Actually, every time testing is a is a good process which help us to provide information to the stakeholders that your product is not ready to release. You need two or three more weeks, because we are working on the quality of the software. So maybe you can provide some very important information which is related to the final decision of the release, especially regarding the level of quality of the test object. To comply, sometimes the objective of testing could be to comply with contractual, legal, or regulatory requirement or standard, and to verify the test object complies with such requirement or standard. Sometimes when you are developing a software, then customer has also signed a contract with you that you will test it, verify it, and validate it. So it's a kind of contractual requirement. And even if customer is not saying to you that you need to test the software, in some countries we have some laws, safety laws. If you are working in automotive domain, then you have some safety protocols. So as per the law of the country, you have to do the testing. So sometimes objective of testing is to meet the its standard requirement as well. So the objective of testing can vary depending upon the context of component or system being tested. Like whatever component you are testing, if you are testing it on a lower level, a module level, or you are testing it on a higher level, then the objective of testing can be varied. And the software development life cycle, we will see everything in detail. Just for timing, just remember that level objective of testing can be different. If you are only testing few lines of code, your objective could be that you should get 100% code coverage. But if you are testing, for example, the whole system, then your objective could be that you are meeting the requirement of customer or not. So in every kind of testing, which we will see in detail in upcoming chapters, your objective can vary. So these different differences may include, for example, during component testing, if you are doing the testing of a single component of your complete project, one objective may be to find as many failures as possible so that the underlying defects are identified and fixed early. So it is one of the objective of component testing. Another objective may be to increase code coverage of the component test. For example, in your component you have 10 line of codes. So this is a very basic unit of your whole project. You will test it and will try to find as many bugs as possible, because when you will integrate two different components, it is component number one, it is component number two. If there is a bug in this component, it will replicate to the next component. So like goal of the testing could be different. Objective in the component testing, your goal could be to find as many failure as possible and to increase the code coverage. And during acceptance testing, which is the final phase of testing, I will explain you all of these things in future. One objective may be to confirm that system work as expected. Like customer is with you, he is going to accept the product and acceptance testing is going on. So maybe during acceptance testing we will not see that code coverage is 100%, and for example but we will see that it is working as expected and satisfy the requirement. Another objective of this testing may be to give information to the stakeholder about the risk of releasing the system at a given time. So when customer is with you and you are showing him the final product and telling him maybe some testing is left and we have to improve the code, so kindly give us 2 more weeks. Don't plan to release this code or this software within 2 weeks. So this testing can provide some decision making information to the stakeholders itself. So like the risk of releasing something, you can tell them during acceptance testing that to the customer when he is with you on your site and you are showing him your product and telling him, yeah, it's a bit tricky to release within upcoming weeks. So maybe you have to think about it and you can postpone the this release maybe to next 3 or 4 weeks. So actually these are the objective of testing. Now there is a concept which is testing and debugging. Actually testing and debugging is really important as far as this ISTQB test is concerned. Actually in testing and debugging there are two different terms. Like testing is somehow different as compared to the debugging. We will try to read this part and then maybe we can discuss in more details. So testing and debugging are different. Executing tests that can show failures that are caused by the defects in the software. So actually testing is you are running your test cases on your code and trying to find the defects in that. If defect is reported, then you will tell the developer. But debugging actually is the development activity that finds, analyzes and fixes such defects. For example, you had a software called A, you run some test cases and you came to know about some, like say bug number 1, and then you told your developer that I have found this bug, my code is not working as expected. Then developer in his or her integrated development environment, what will he or she do? That will try to run the code, debug the code, and will try to find the defect and fix it. So this is the term. Actually debugging actually identify where the problem exactly is, and testing tells you there is a problem in the code. Tester will report to the developer that there is a problem in the code, kindly check it, and then tester or developer in his or her development environment will run the code and will try to debug where the problem exactly is. So like it's a debugging. Subsequent confirmation testing check whether the fixes resolve the defects. Then when here was a tester and he has found some bug given to the developer. Developer checked it, debugged it, and removed the fault, then give it back to the tester. He will recheck it or reconfirm it, or confirmation testing we can say. This we will also see in upcoming chapters. And then if the defect is resolved, then your bug is closed. In some cases, testers are responsible for the initial test and the final confirmation test, while the developers do the debugging, associated component and component integration, continuous integration testing. Like sometimes this you have written a code, developer has written the code, and then even after the development, uh, the unit testing, or also known as component testing, we will see in chapter number 2 about the different levels of testing. So maybe sometime in some project, developer does the development plus unit testing as well, and finds the problem. However, in agile development and in some other software development lifecycle, tester may involved in debugging and component testing. It's quite possible. Agile is a we will see in chapter number 2. Agile is a software development lifecycle methodology which is used to develop any software. So it is possible that in some cases testers are responsible to do the unit testing, and then they find some bug, they give it to developer, he debug it, fix the defect, give it back to the tester, he will run it, confirm it, and it's done. But in some agile development methods, it's like this: we have developer develop the code and also does the unit testing on it and find the bug and fix it. So it's a kind of different thing. So just for time being, just remember that debugging actually is to identify the cause of defect and remove the bug or defect. Here I will tell you a very important thing, that just remember this: bug, defect, or fault. You can call this as B, F, D, or whatever you want. B, D, F. Bug, defect, and fault, they all are the same thing, same name. Like there is a bug in the code, there is a defect in the code, there is a fault in the code. These all are the same terms. We will see in more detail in the upcoming section, I think 1.3, in more detail about the bug, defect, and faults. Just for timing, just remember that these all are the same names. And debugging is about running a test, debugging your finding the defect in the code, or bug in the code, or fault in the code, and removing it. And testing is to execute a test case and try to find the fault in the code. So this was section 1.1 which we have completed. Now in the next video we will move to section 1.2, which is about why is testing necessary.